SMIC Studios. Hello, welcome to SMIC Studios. I'm Conrad Leyva.
And I'm Mike Yost.
And today we're here with two distinguished guests from North Carolina State University. This will be a 20-minute broadcast. We will take your questions via the Q&A feature in Zoom. And if you can't figure that out, don't worry. I mean, I know I won't. I mean, we really want this conversation to continue on LinkedIn. So we will answer your questions via the LinkedIn group, and we will give you that link at the end. Today, we're here to discuss how North Carolina State is responding to the COVID pandemic and how they are leveraging their systems and their manufacturing facilities towards the creation of, towards that response to the pandemic and the help with medical equipment.
Yeah, and before we have our guests introduce themselves, just quick background for those of you who are new to our webcast, what we're all about, what we're trying to accomplish here, and why in the world do we call this 6 degrees of smart manufacturing. It's really based on the principles that everybody on the planet's only 6 degrees of separation from knowing everybody else. And so from our perspective, we think the best way to share knowledge that we need to make smart manufacturing a reality is by getting the insights and perspectives from as many people as we can. So with that in mind, to Conrad's point, we wanted to bring our guests with us here to talk primarily two areas. Yesterday, we made an announcement that we formalized between CESMII and NC State a formal Smart Manufacturing Innovation Center on the campus at NC State. So we're talk about that briefly, and then to Conrad's point, we want to talk more directly about the COVID response from the Nonwovens Institute. So, gentlemen, if you could introduce yourselves here to our guests quickly.
Okay, I would go first. My name is Yuan-Shin Lee. I'm a faculty at the NC State University. We are very excited with the collaboration with the CESMII that we established this new Smart Manufacturing Innovation Center, SMIC Center at the NC State on campus. We have the world-class facility, and we are very excited with this opportunity. And as a result, given the COVID-19 virus, and it just demonstrate how smart manufacturing is able to adapt it, reconfigure it, to respond the national urgent need. So in a way, I think we are very excited for this new opportunity and really look forward to the future potential working with CESMII. Thanks.
Excellent, thank you. Behnam, I believe your microphone is muted. Behnam, that's...
All right, yeah, good morning. I'm Behnam Pourdeyhimi, professor at NC State, and also the director of the Nonwovens Institute.
Excellent. And we're going to hear a lot more from Behnam, starting with a video that they produced that, it's a 3-minute video that explains what he and his team are up to. So everybody sit and listen to this.
Yeah, I love this video.
Yeah.
If you look at it, the N95 mask or the surgical mask, they would always have 2 common nonwovens in them. One would be the filter layer, which is actually a melt-blown fabric. And then you would have the spun-bond fabric, which is not really the filter, but it supports and provides support for the melt-blown layer. So these are what are used in all the PPEs that we have today. We are fortunate to have large-scale pilot facilities, both for spun-bond as well as melt-blown. And also our spun bond is actually quite unique. So we have quite a bit of capacity in terms of what we can do to actually help build filters. We can actually make a lot. So typically we talk about kilograms per hour or meters per hour. So we're roughly running right now about 2,000 meters an hour. And we're doing extended shifts. We're doing 12-hour shifts. So in a day, we actually make about 20,000 meters of the filter. We're trying to ramp up that and see if we can actually up the production because of the need that exists. And so with the classical masks, 1 meter would make 25 masks. So when you talk about running at 40 meters a minute, That's basically 1,000 would equal 1,000 classical masks a minute. We have actually been working with a number of key partners in North Carolina who have the abilities to take these media and make them into masks. And so we are in dialogue with a number of them, and this is going to happen very, very shortly. We actually looked at North Carolina and beyond in terms of what is missing. There's a shortage of automated capacity for making masks. And so the Nonwoven Institute, with help from the Keenan Institute, from the Provost's office, from the Vice Chancellor for Research's office, and the NC State community, we came together and actually ordered 2 machines. These machines will be delivered within 3 or 4 weeks, and we actually will set these up, and we will take our own media and convert them into masks, and then be able to provide masks to the local communities. I've never actually seen a community come together like we have. So we are in discussion with a number of healthcare providers in North Carolina, but we'll also be talking to the DHHS, Department of Health and Human Services. North Carolina has the largest number of nonwoven companies in the nation, and so we are reaching out to them to see if they would also invest in converting machines or invest in extra capacity. We're looking at possibly changing the way they're producing things so that we might be able to produce filters that would be useful during this crisis. So we're putting a lot of partnerships in place to be able to expand the amount of materials that are available to us.
Hi. So, Behnam, would you please expand on that video? Tell us about that process of quickly shifting gears to deliver this much material. I mean, material for about 1,000 masks per minute. I mean, that's an impressive shift. Tell us about it.
So I think one thing that we learned really quickly was that when you take a very complex process and you try to do bench scale or lab scale or smaller scale, ultimately it doesn't really scale up in terms of the final performance. So we've built a whole series of facilities where we do materials development on a smaller scale, but then when you really are trying to do process development, where you have about a dozen different processes that have to work together to deliver that final product, you really have no choice but to have something that's really closer to the marketplace. And so the 2 pilot facilities that we have, one for spun bond and one for melt blown, the video was for the spun bond, but we also have a very large scale melt blown facility across the street. So these are essentially the same as what you would find as the state of the art, the best that you can find. And so that gives us the ability to really ramp up and not only do the basic research, but then really translate that into a product and a process that could be easily commercialized by others. And so just for your information, you know, one of the things I said in the video was that I was trying to up the throughput, and we've actually gone now to 3,000 meters an hour. So we've increased it by almost 50%, and we haven't stopped there yet. And of course, in order to do that, it takes a lot of effort in terms of really understanding the structure, property, process relationships, and how you can turn the knobs in order to be able to do that.
Yeah, that's a great point. So I was going to actually ask you about that. Maybe talk a little bit more about the process that you're going through to maximize your output, your throughput. You know, do you have automation in place? Are you relying on the expertise of operators? How are you guys approaching it?
So I think, so I can talk in really 2 respects. One, what the machine is today and what the machine could be tomorrow in terms of what one could do to advance it even further. So this machine is fully automated. We have more sensors that got created on this machine. We can monitor everything from the polymer delivery to the extrusion to how we quench the fibers and create crystalline structures, to how we draw the fibers by aerodynamics, and how we then take those filaments and using aerodynamics, lay them down on a web to create a web, and then how we bond them. And we use a series of water jets to essentially do that. And then once you get to the end of it, which is the winder has to be absolutely fully automated. To just put it in perspective, it takes about 6 minutes to make a roll. And if you didn't have automation, it would take you 15 minutes to take it off the machine. And so we actually have a robotic system at the very end where we essentially get the roll moved to a safe position where the operators only essentially have to pull the roll out and just put another core in there. And so the process really from the beginning, from the polymer delivery all the way to the extrusion, all the way to the lay down of the fibers, and then the wind up is monitored continuously. We actually look at the trends. And one of the interesting things that happens is that, you do get defects and you get shutdowns. And so we have to be able to go from a shutdown back to a startup really quickly. And currently we do that almost within 20 minutes. And of course, the reason we know how to do that is that the trending data and all the data that we've created in terms of creating these recipes, we have. So essentially what we do is we just put all that information back into the system and we'll be up and running. The missing link here, yeah, go ahead.
So that data was very important. And this is data that you had from before and on how the machine operated. Were you able to leverage the data and the systems you had in place to do this pivot?
Right, so we absolutely have to do that. So we were fortunate because we had developed some interesting structures for mechanical HEPA filters. And so when this crisis happened, we started with that sort of data that we had. And we said, what do we need to do in order to change the structure so that we create something that has high efficiency, but a much lower pressure drop, so that it will be easier to breathe. The HEPA filter has very high pressure drop. So without the existing data, we would not be able to do what we've done currently. And I was going to comment that I think every roll that comes off, we monitor the data that, and then we essentially test every piece of material that comes off the machine. And so the missing link is really where we cannot measure performance and properties online while we're making the fabric. And so one of the things that we're now considering is how can you do that on the fly? So that when now you don't have to actually have a delay in terms of looking at if something went wrong with the structure, but rather how can you just detect it immediately and adjust it.
Do any of you think that your whole manufacturing centric education and all these assets you have in this learning center, do you think today's environment has shifted more focus towards that center or less because people are worried about the pandemic? How do you feel the whole university system and is reacting to this?
Yeah, I think the reaction has been interesting. So I get about 1,000 emails a day. Of course, we have a large community. We have a consortium of 78 companies that we work with. We have 50 PhD students that we support. So all of that still continues, but I think what's happened is that our activities have quadrupled and really focused sharply on dealing with the current crisis. So both pilot lines are running. We're running 7 days a week. Starting next week, one of the pilot lines will actually go 24/7. And so we'll have the capability to help in some small way.
And Conrad, for that, I would like to chip in that think this way. The SMIC Center, the NC State just being started, and while we are saying, we are talking, we are doing, just starting, and pandemic COVID-19 happens. So a lot of things just happens. And what the point I want to make it is due to the smart manufacturing capability now that the same machine, the same hardware system that Behnam is able, and he and his colleague are able to double the production, triple the production foreseen with the same hardware is primarily due to the smart manufacturing. So while we are talking about these, we are also demonstrating how we can configure this capacity by knowing the bottleneck and overcome it, and you can maximize double, triple your productivity by doing smart manufacturing. That's the point I want to make.
Yeah, and, thank you, Yuan-Shin. Behnam, I think it's a very interesting point. I think people we've lived with for a long time. Like, when do you consider the need for data access, intelligence, visualization, reporting, et cetera? And historically, what we've seen is manufacturers specifically go out and solve a specific problem in a particular area. They respond to a particular need. Not really a consideration for broader, strategies on data collection and enterprise analytics or things like that. So, seems to me that there's I guess maybe if you could comment, Behnam, as this crisis hit, maybe the thought process of your teams. You talked about buying 2 additional machines that are coming in. You guys didn't sit down, I'm assuming, with an enterprise architecture plan of how this is going to fit into data structures and such. It's more, how do we solve this problem immediately? And then potentially, I think, longer term through the SMIC, as Yuan-Shin talked about, we have the ability to come back, layer some infrastructure on top of that, and start to drive some value out of the data that's being produced.
Right, so I think maybe I'll take a step back. I think if you look at a non-woven structure, it's essentially the performance is defect driven. So if you have, for example, a couple of pinholes here, if you have a couple of molten drops of polymer here and there, your filtration efficiency will go to almost nothing. And so in the simplest form, what we are in the process of doing and thinking is you put a series of cameras on there and you look for defects and you close the loop in terms of where those defects are, because when you make a jumbo roll, you can't really throw away the jumbo roll, but you want to tag where those defects are so that during the conversion process, you don't actually take that material and form it into a final product. But once you get into a really technical product such as filtration, where 1 or 2% in efficiency could be the difference between pass or fail with respect to the standards that we have. The challenge is that you cannot currently do that online. And so we are actually thinking of how we can, from the knowledge base that we have and understanding the geometry and the structure, how could we measure simple things, for example, such as the fiber size distribution and the air permeability, which would be rather simple to measure online, and then correlate that and translate that back into how that transforms in terms of the filtration efficiency and the pressure drops in the system. So I think there's a great deal of opportunity to actually go far beyond where we are, and I think we see the need for that currently. We are working with a couple of companies up north who are trying to convert their existing machinery to be able to do N95 masks, and they're struggling because of that, because they don't really know how to close the loop. The testing facilities are not readily available. And so I think that there's a lot of opportunities to go beyond where we are today.
So how many partners, so you're delivering this material to about how many partners or in your ecosystem how does it get from material to the masks?
So really, I think the differentiation is the following, that typically all masks today are made on fully automated machines, where you essentially unwind different materials and you put them together and you even package them together. The challenge is that there's a shortage of converting capacity. There are not enough machines in the US to do that conversion. So one of the fabrics that we developed, the spun bond, actually lends itself to being handled by other types of machinery. And so if you have automated cutting machines, if you have cut and sew capability, you could actually take this fabric and convert it. And so that immediately expanded the horizon in terms of capacity. So we have put really a network of partners together, and they're not just here, they go all the way from North Carolina to the West Coast. And we're shipping thousands and thousands of meters of fabrics out to these partners. We have a very large partner in North Carolina, but there will be a press release about that in a few days, and I won't steal that thunder.
Okay.
Well, and guys, I promised you I would be bad cop and keep an eye on the time, and unfortunately we are out of time. I think that we can continue our conversation offline and post additional information for folks. Yuan-Shin, we plan to talk more about the the Innovation Center announcement, the SMIC announcement. I'd say we take that conversation offline with us. Definitely want to see how the actions that are taking place right now within the Nonwovens Institute, translate to broader learnings, broader education, best practices for future generations. And I think the SMIC setup and the assets you guys have there certainly lends itself well to do that. But we're going to wrap up and ask one final question. I think, Behnam, if we could throw this at you.
Yeah, I want to ask, so I saw that North Carolina State has that saying, think and do. I love that saying, and you're definitely not just thinking, you're doing with your machinery here. But I want to know if on the thinking side, if this whole new process, this response has inspired new ways of thinking for you, maybe new research or methods or even priorities for smart manufacturing.
Absolutely, and I think part of it is really, closing the loop, because we use a lot of different technologies, and a good example is on the melt-blown machine. We had to develop a electrostatic charging unit. These you can't buy. So we actually, our engineers designed them in 2 weeks. We built them. We actually had to learn how to get that to talk to the melt-blown machine so that in sync. And so I think there's a lot of opportunities to do things beyond where we've been. And there's a lot of learning that's coming from this. We're actually collecting data. And the data, we're looking at the trending. We're trying to look at what the variations are due to so that we can then diagnose them. So I think this has been a really tremendous experience, and we'll have a lot of data that we're going to have fun analyzing.
Yeah, what I would like to chip in is that this certainly gives us the opportunity looking to break the barrier, and we look the problem solving from industry driven, as well as from academic side. We use a holistic approach that not only you are focused in one discipline area, instead you need to integrate technology from all different areas. So that gives us this new thinking towards a new challenge that we are facing. So that's my feedback. Thanks.
Appreciate that from both of you. Appreciate what your university is doing, what your teams are doing, running 24/7 to respond. We've been talking a lot internally, sort of in two dimensions nowadays. There's response and there's recovery. And what you're doing right now from a response perspective is admirable. We appreciate what you're doing. And I think it's perfectly set up to help us from a recovery perspective to learn together. So thank you for what you are doing. Thank you for sharing of yourselves. Would encourage everybody who's watching this with us to go online. We will post this recording online, and we'll keep the conversations going. I haven't been able to keep up with the chats, but I see that they're blowing up here. Lots of stuff coming in from folks. So go online. We'll continue the conversation. We'll also continue and post additional content as we can through a bonus reel as we go offline here in just a minute. But so everybody knows, the webcast series is set up to go on the second and fourth Wednesday of every month. So we'll be back here again. Conrad and I will on May 13th. And so come back, check the CESMII website, stay plugged in with us, and be a part of this. So with that, I want to thank you, gentlemen, again for your time today, your expertise, and all that you're doing here. And wish everybody a great day, and stay safe. And we'll see you again soon. Take care.
Bye.
Yeah.
Bye-bye.
Bye. Thank you.